Hello everyone, this is the part 2 of the review of the central limit theorem. So the first question is let's see, population size is 90,000 and the sample size is 18,000. Standard deviation is given, which is 50, and they ask you to compute the standard error of x bar. Okay, so I go to the Excel page. Here it is. Sample size is 90,000, yes, and 18,000, and sample standard deviation is 50. So I use the standard error formula, s over square root of n, and this part in two stages. First stage I compute this part, you can see s over square root of n, and then the second part I compute the finite population correction, which is this, and then I multiply those together. I get standard error as 0.333. Okay, next question. In this question is the same question basically. You need to compute the confidence interval for the proportion. This is given, 0.39 is given, so you just need to compute this part. Okay, so 0.39, population size is 6,300, sample size 1,500, and approximate 95% confidence interval. This is important to pay attention, approximate. I will explain to you in a second. Okay, so this is P.93, 6,300 population size, 1,500 sample size. I calculate the standard error first in two steps again. First part is this, second part is that. So first part I calculate this in this way. P times 1 minus P over 1,500, the whole thing under square root. You can see the whole thing under square root. And then this is also square root of n minus 1 divided by the population size minus sample size divided by the population size. Now I multiply both of those and I get this standard error, okay, which is this. Now the difference between the confidence interval and approximate confidence interval is that in the approximate you don't use z. That's my understanding. So that's why P plus minus standard error. So standard error is 0.011. Let's see. 0.011. Next question. Now in this case, the sample data set is given, the large sample, relatively speaking. So I export it to Excel page and by clicking this button, and then estimate. Let me reduce it a little bit. So estimate mu with an approximate 95% confidence interval. So basically you need to approximate 95% confidence interval. Okay, 95% confidence interval. I go there. Now, so I have this, I exported the data and I computed the mean and the variance. So this is the mean and this is the standard deviation. This is the standard deviation. So I got finite population correction is this, and my mean is 39. Mean is 39, and the variance is standard error, or standard deviation rather, is 13.518. So I got the standard error by using this formula. Okay, you can see that I calculate finite population correction here and standard deviation here. So in this formula, standard deviation divided by square root of n, which is 20, times finite population correction. Okay, now error, I got it here, but that's a dilemma. Here they have used a t-statistics at 5% level of degrees of freedom, and it should not be. It should be just this, according to the previous exercise, because the question is asking for approximate 95% confidence interval. So, approximate confidence interval. But anyway, when I use this one, I get 5.764. So I'm assuming that's a mistake on their part. It's not approximate, it's a real confidence interval. It is the confidence interval, 95% confidence interval. 39 plus minus 5.76, okay? And then for the second part, it says estimate the p proportion of measurements in the population that are greater than 30. So basically very simple. You count how many of them are greater than 30, and I have found 13 out of 20. So the proportion is 13 out of 20 is 65, and I calculated the standard error, and I found the error is 0.213. So this plus minus 0.213, let's say. This plus minus 0.213. Okay, next question. Next question is, let me enlarge it a little bit. Again, it's the same thing. Basically, sample distribution is given to you. You need to estimate the mean and estimate the standard error. I export the data set into Excel, and I calculate the mean and the variance, okay? Now the steps for calculating the mean and the variance of a frequency distribution, it's basically a frequency distribution. You need to review the link 1 in the comment section. I have given all the steps, okay? So, mean is this, variance is this. So from there, I calculate the standard deviation just by taking the square root of this, and then I calculate S over square root of n, and this is finite population correction. When I multiply these two, I get this one, which is right here. Okay, now Z alpha depends on what is 95% or 90%. This is, give the value of the inventory, find the estimate standard error of the point of 95% confidence interval. Okay, so 95% confidence interval, Z alpha 0.05 over 2. Remember, for the Z, you need to divide by 2. For T, you do not. So this is the error. Now it is very simple. You add and subtract from this one. When you add, you get, remember, add means when you subtract 2 negative makes it positive. So you're adding 65.24, 50.56. So that's the whole answer. So let's check. Mean 57.90. 57.90. Standard error 3.75. Standard error 3.75. Confidence interval 50.56, 65.24. 50.56, 65.24. Okay? That is it. So that concludes the review. Thank you. Bye.